All right, how to solve trigonometric equations in quadratic form. Let's go. All right, before we actually solve some trig equations, we want to first review the unit circle and how to use it. This is going to be a quick review. At this point, if you're starting to solve trig equations, then you should have a really good understanding of the unit circle. So to find the exact value of sine of pi over 6, you want to first find pi over 6 on unit circle. Hopefully you can visualize this at this point without the actual unit circle in front of you. If you can't, try to get to a point where you can just visualize this and maybe picture it in your head. But for now, let's just look at the unit circle that's in front of us. Find pi over 6 on unit circle, which is here. The sine value is the y coordinate. So sine of pi over 6 is 1/2. All right, to find cosine of 2 pi over 3, we again find or visualize where 2 pi over 3 is on the unit circle, or we can use something called reference angles. However you find this exact value, just make sure you're very careful in finding it correctly. So cosine of 2 pi over 3, find 2 pi over 3 on your unit circle. Cosine is the x value, and so cosine of 2 pi over 3 is -1/2. All right, tangent, 5 pi over 4. Remember the quotient rule for tangent. We know tangent of some angle is equal to sine of that angle divided by cosine of that angle. So tangent theta is equal to sine theta divided by cosine theta. And so to find the tangent value, you're going to find the angle 5 pi over 4. Remember, sine is your y, cosine is your x. Notice they are the exact same. When you divide something by itself, you get 1. All right, let's do one more. All right, what if you're asked to do something like this? Find angles on the interval 0 to 2 pi such that sine of theta is equal to √3/2. We're still going to use the unit circle, but this time we're going to use it in reverse in a way. What we want to do is look on the unit circle and find at which coordinates is the y value √3/2. And so if you look very carefully, you'll find those angles are here and here. And so on the interval 0 to 2 pi, sine of pi over 3 is equal to √3/2, and so is sine of 2 pi over 3. All right, and it's this way that we need to actually view the unit circle to solve trig equations. So let's actually see a trig equation. We're going to start out with what I'm going to consider a warm-up problem. This is not a trigonometric equation in quadratic form. We want to warm up to that. The next problem we see will be in quadratic form. This problem here is a trigonometric equation, but it's in linear form. Both signs that you see in this equation are both linear terms, sine to the first power. Okay, so we're going to treat this like a regular linear equation. What I mean by that is, instead of looking at this like a trig equation, 5 sine x is equal to 3 sine x plus the square root of 3, we want to just think of that sine x as being just any variable. So kind of think about substituting something in for that x. Maybe p. If you're asked to solve this equation, could you do it? 5p is equal to 3p plus 7, all right? What would you do? Voice is always cracking. You would move over that 3p. You'd be left with 2p equals 7. You divide by the coefficient of p to get p by itself. P is equal to 7/2, or 3.5. Okay, so there's nothing difficult about this. We can agree with that. What we want to do is treat this trigonometric equation just like we treated that, as if it's a linear equation. So what would we do in the equation 5 sine x is equal to 3 sine x plus the square root of 3? Well, we want to get the sine x terms together. So we would move over the 3 sine x. To move that over, we would subtract it. So what's 5 sine x minus 3 sine x? Well, that's 2 sine x. And so we'd be left with 2 sine x is equal to the square root of 3. Okay, we want to get sine x isolated. We want to get it by itself. It's being multiplied by 2, so we're going to divide by 2. When we divide by 2, we'll be left with sine x is equal to the square root of 3/2. Now, you do have to be very careful with trigonometric equations. This particular problem is asking me to find all solutions. So let me explain what that means to do. Well, we just talked about where on the unit circle is the sine value square root of 3 over 2. And those angles were pi over 3 and 2 pi over 3. Okay? But when it says find all solutions, what that means to do is we're not only looking for the angles in between 0 and 2 pi, we want to consider every angle that gives us a sine value of root 3 over 2. So we do need to use the unit circle to find our initial answers, which are pi over 3 and 2 pi over 3. But if we're asked to provide all solutions, you need to remember that sine is a periodic function, as well as cosine, tangent, secant, cosecant, and cotangent. So you have to remember that there is an infinite number of solutions to this particular equation. And to find those, just think about coterminal angles. Yes, sine at pi over 3 equals square root of 3 over 2. I guarantee if you add 2 pi to pi over 3, sine of that angle also equals square root of 3 over 2. So what we need to do is say, okay, our answers are pi over 3 plus any coterminal angle to pi over 3. So add 2 pi n. And we need to define n as being an integer between negative infinity and infinity. 0, 1, 2, 3, 4, 5, as well as negative 1, negative 2, negative 3, and so on. So if you plug any of those values in for n, those coterminal angles will also give you a sine value of square root of 3 over 2. But we actually have to write down that n is an integer. So this is the way I like to write it down. N is an element of the integer set. Boom. So we've defined n. Now to the second answer, we're just going to attach the plus 2 pi n. And we're done. So those are all the solutions to that equation above. All right. Now let's take this and let's look at a trigonometric equation in quadratic form. All right. Yeah. So now if we're looking at our main problem, find all solutions to the equation 2 sine squared x minus 3 sine x plus 1 equals 0. So the trick to these problems is to also view this as if it's a regular algebraic quadratic equation. So just like we did before, we kind of substituted something in for that trig function. All right. In the other problem, we substituted a p. We said, okay, what if our sine was p? We substituted a p. We could do something very similar to this. We could say, well, if the sine x is equal to p, we could consider this, right? If sine x is equal to p or any other variable, just to substitute it in, then we'll be left with 2p squared minus 3p plus 1 is equal to 0. Solve for p. This is a regular quadratic equation, right? How would you solve this? If you need help factoring this, I talked about factoring quadratic expressions using the bottoms up method in my previous video. Check that out. But I'll go through it quickly here. The bottoms up method says we can multiply the leading coefficient with the constant term. So 2 times 1 is 2. Find factors of 2. Well, that's easy. It's just 1 and 2. How can you combine these factors to not only multiply to give a positive 2, but also to add to give a negative 3? Well, make them both negative. All right, and bottoms up says if we have a leading coefficient that is not 1, such as this, we could take these values, negative 1, negative 2, divide them by the a value, which is 2, reduce when possible, so negative 2 over 2 does reduce the negative 1 over 1, and then bring the bottom up to complete the factoring. Bottoms up, bring the bottom up. And so the factors would be 2x minus 1, or excuse me, 2p minus 1, and p minus 1. And so if we wanted to solve this, the one we're considering, we would just set these factors equal to 0 and get p is equal to 1/2 and p is equal to 1. Okay, so treat this as if it's a regular quadratic. Now let's talk about the actual equation. If 2p squared minus 3p plus 1 factors down to 2p minus 1 times p minus 1, well, 2 sine squared x minus 3 sine x plus 1 will factor down to this. 2 sine x minus 1 times sine x minus 1. And again, you can just resubstitute what p was earlier. Okay, set those equal to 0. 2 sine x minus 1 equals 0. Sine x minus 1 equals 0. and solve. Okay, so get your sine x's isolated. So in the left equation, you'll have sine x is equal to 1/2. In the right equation, you'll have sine x is equal to 1. And then find where on the unit circle are your y values 1/2, and those will be at these angles, pi over 6 and 5 pi over 6. Remember, we're looking for all solutions, so we're going to say plus 2 pi n and define n as being an integer. So those two expressions will give me the solutions to the left equation, sine x is equal to 1/2, but we also have to think about sine x being equal to 1. And so where does that happen? Well, that happens at pi over 2. So the remaining portion of our solution set would be x is equal to pi over 2 plus 2 pi n. So when you're asked to solve trigonometric equations in quadratic form, try your best to see if you can factor the quadratic as if it's a quadratic that you've probably factored 100 times in an algebra course, and then solve it just like we did here. But remember, we only found all solutions. Now, if you're ever asked to find solution sets on particular intervals, then you have to think about what n values fit. But we'll talk about that at another date. If you need any other help or have any questions about this video, let me know.